Hello, my name is Marta, and in this video I will explain sequences. I will tell you what a sequence is, terms, general term, recurrence, relation, divergent, convergent, and periodic sequences. A sequence is a set of numbers with a rule to it. So if there is a list of numbers which follow a rule, that's a sequence. Let's say 7, 11, 15, 19, and so on. It's a list of numbers. The rule is add 4, because 7 plus 4 is 11, 11 plus 4 is 15, 15 plus 4 is 19, and so on. So the rule is add 4, and it's a list of numbers. So that's an example of a sequence. A term is a number in a sequence. So terms are the numbers. And the first term in our case is 7. So we say that u1 is 7. That means that the first term is 7. u2 is 11. u3 is 15, and so on. These are the terms. General term or the nth term we can give using a general formula. In this case, it is 4n plus 3. That's the general formula, and that's the recipe for the nth term. So any term in this sequence can be calculated using this formula. So if I want to calculate the first term, I simply substitute 1 for n. N stands for the number of term. So the first term is 4 times 1 plus 3, and that is 7, which is confirmed by my list. But I'm just showing you how to use the general formula to calculate the terms. u2 is the second term, and using the formula, I just substitute 2 for n, and it's 4 times 2 plus 3, which is 11. u3 is 4 times 3 plus 3, which is 15, and so on. And un in general is 4 times n plus 3. So I can calculate even u100, which is the 100th term, and that would be 4 times 100 plus 3 is 403. Okay, let's take a look at the next example. Write down the first 3 terms and the 10th term of the sequence whose nth term is given by. Okay, this should be given. Given by un is 3n minus 2. Okay, the first 3 terms, so u1, u2, and u3. To calculate u1, I substitute 1 into my formula. Now n is 1, so that will be 3 times 1 minus 2, and that is 1. So the first term is actually 1. The second term will be 3 times 2 minus 2. I just substitute 2 for n, and that would be 4. And the third term, I substitute 3 for n in the formula, and so I have 3 times 3 minus 2, which is 7. These are the first 3 terms. And I can also calculate, as I am asked to do here, I can calculate the 10th term. The 10th term, so u10, so that will be 3 times 10 minus 2, which is 28. And there you go. You have the 10th term. Let's take a look at the next example. Find an expression for the nth term of the sequence 8, 14, 20, 26, and so on. Okay, so now I know that when n is 1, u1, the first term, is 8. For n equal to 2, that's u2 is 14. and then the next one is 20, and then 26. So U3 is 20, and then U4 is 26. And I have to find the formula. So the formula for the nth term in general formula. Right, so I have to find the relation here, how to get from 1 to 8, from 2 to 14, from 3 to 20, and from 4 to 26. Since the difference between these terms is 6, it's like 6 more, 6 more, 6 more, I would suspect that that will have something to do with 6n. Because if you have 6n, that automatically makes each term 6 more than the previous one, right? Because then U1 will be 6, then the next one will be 12, 18, and so on. So for UN6n, you get the difference of 6 between the terms. But this is not quite what we wanted to get, because actually in our sequence, it is not 6, 12, 18, and 24, but it's a good start. Okay, so I will start with 6n. Now the problem is that I actually want to get 8, 14, 20, and 26. And that's okay, that's just 2 more. So I will just add 2. And if I do it, I just have U1, 6 times 1 plus 2, which is 8. U2, 6 times 2 plus 2, which is 14. U3, 6 times 3 plus 2, which is 20. And U4, 6 times 4 plus 2, which is 26. So this is what I wanted to get. So this is the formula for this sequence. Let's take a look at the next example. Find an expression for the nth term of the sequence 1, 4, 9, 16. Okay, let's try. So for n equal to 1, U1 is 1. Then if n is 2, that U2 is 4. For n equal to 3, U3 is 9. And for n equal to 4, U4 is 16. So now I have to get from 1 to 1. So I need a formula which will turn 1 into 1, 2 into 4, 3 into 9, and 4 into 16. Again, I just have to try to match a relation. I think I have it. 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. So that would be it. N squared is the formula for this sequence. Let's take a look at the next example. The next example will be actually a different type of formula. We'll move on to a recurrence relation. In recurrence relation, you use the previous term to get the next one. That makes sense. So in the recurrence relation, you should always give the first term, and then to get the next term, you use the formula. So the formula is not in terms of n, it's in terms of the previous term in the sequence, the previous number. Okay, so let's try. We should find the first 3 terms of the sequence. Okay, U1 is very easy to find because it was given, so that's 5. Now, U2 is, okay, UN plus 1 is UN plus 3. That basically means that the next term is the previous one plus 3. So U2 is the last one was U1 plus 3. That's how I should understand this formula. So basically it says, get whatever number you had before and add 3. That's how I understand this formula. So u2 is 5 plus 3, so 8. u3, again, you take the previous one, so u2, and you add 3. And 8 plus 3 is 11. I wanted to find only the first 3 terms, but I will go crazy, find the fourth one just for fun. u4 will be u3 plus 3, so 14. And so on and so on. That's the recurrence formula. Let's try the next example. Oh, find the first 4 terms of the sequence. Okay, so now we have to find the first 4. Oh, and the formula is actually fancy. It doesn't use the previous term, but actually the previous 2 terms. Okay, let's try it. u1 is 2. Okay, u1 is 2. I just found my first term. u2 is 5. Okay, u2 is 5. And then un plus 1 is un plus un minus 1. So I understand this formula that I have to create the next term, I have to take 2 previous ones, un and un minus 1, and add them together. So u3, following this formula, will be 5 plus 2, which is 7. I just take, this is un plus 1, I take un and un minus 1. So I take u2 and u1. Let's try another one. u4 will be u3 plus u2, and that will be 5 plus 7, which is 12. One more. Let's find u5. That will be u4 plus u3. u4 plus u3, 12 plus 7, which is 19. And there you go. You can find even more terms using this formula. The only problem is that if you use this formula to find the next one, you have to always use the previous ones. So to get to the 100th term, I will have to perform a lot of calculations. Whereas in the general formula, I could just substitute and it was done. Okay, now moving on to convergent, divergent, and periodic sequences. Convergent means that a sequence approaches a limit, tends to a limit. When n is bigger, 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 tends to infinity, un, the terms, and tend to a certain limit. So they approach a limit. Divergent means that they don't. So it is not approaching a limit. And periodic means that the terms repeat. There's like a repeated pattern. Let me explain on examples. The first one will be convergent. The example is un is 2 to the power of minus n. Let's try to list the terms to see why I underline it as convergent. The first term will be 2 to the power of minus 1, right? u1 is 2 to the power of minus 1, which is half. The second term is 2 to the power of minus 2, which is quarter. Then 2 to the power of minus 3, that's 1/8. I will just list the terms. I will just list the terms by substituting n equal 1, 2, 3, 4, and so on. And now you might see that the when n is getting bigger, bigger, when n tends to infinity, the un, so the terms tend to a limit, a number, because we can see that they are getting smaller and smaller and they are approaching a number. I think you will see it better if we list those as decimals. The first one is half, quarter, 1/8. We can use a calculator. 1/16, that's 0.0625, then 1/32, and so on, well, 0.03125, and so on and so on. Let's try with the last one to clearly see the pattern. 1/1024, that's 0.00097. Let's say 0.00098. And the next one will be even closer to 0. Okay, so we say that when n tends to infinity, un tends to 0. 0 is the limit. And that means that the sequence is convergent. Convergent. It gets closer and closer to a certain value. The second one will not be convergent. That means that it will be divergent. Let's list the terms so you can observe it. u1 is 3 times 1 plus 1, which is 4. Then u2 is 3 times 2 plus 1, which is 7. Then we have 10, 13, 16, and so on, 19, and so on, and so on. So if it doesn't approach any number, it just goes straight to infinity, that's divergent. Let me draw it for you. Convergent looked like this. Convergent, the first term was half, then the second term was 1/4, then the third term was 1/8, and it went so closer and closer and closer to 0. So there was a limit. But this one, divergent, the first term is 4, second 7, 10, blah, 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 13, 16, and so on and so on. Sky is the limit. It just goes straight to infinity. So that's divergent. That's the difference between convergent and divergent. And the third type is periodic. Why is it periodic? Because, well, I will list it and then you will see. u1 is 5 plus minus 1 to the power of 1, which is 4. u2 is 5 plus minus 1 to the power of 2, which is 6. u3 is 4. u4 is 6. 4, 6, 4, 6. That's how it goes. It means it's periodic. It repeats. The period is 2 because the pattern repeats 4, 6, 4, 6 every 2 terms. Another example would be 156, 156, 156. This one is periodic as well, and the period is 3. Let's take a look at the last example for today. A sequence is defined by un plus 1 is 0.2 times un plus 2, and the first term is 3. The limit of un as n tends to infinity is L. Find the value of L. Okay, so we know that it is a convergent sequence because it was given that there is a limit L. And now there is a question what the limit is. Let's try to list the terms to understand it better. The first term is 3. The second term, u2, is 0.2 times 3 plus 2, which is 2.6. Let's try to find the next one. That would be 0.2 times the previous one, which is 2.6, plus 2. That's 2.52. Let's find the next one. You always take the previous one, multiply it by 0.2, and add 2. So the previous one, the next one is 0.2 times 2.52 and plus 2. That's 2.504. Maybe one more. So now I take 0.2 times 2.504 and add 2. That's 2.5008. So I can observe that it is convergent. When n tends to infinity, un terms tend to a number, which is the limit. You can guess the limit, but I can show you, well, guessing is an amazing mathematical approach, but maybe let's try to calculate it. I mean, you probably guessed the limit by now, just by looking at those numbers, but this is not a proper mathematical strategy to guess something. To calculate the limit, we can assume, or we can just say that far away in the sequence, when n is very close to infinity, the two terms are very close to each other and they are very close to the limit. right? Because if we take two terms which are almost like the last two terms in the sequence, which is impossible because there's like infinitely many terms. But we just imagine that they are approximately equal to each other and equal to the limit. So that's what we assume here, that un and un plus 1 are very close to each other, and they're very close to the limit when they are. So we could say that, oh, in infinity they are equal. And then we can substitute what we have here. We know that un plus 1 is 0.2 un 0.2 un plus 2, and that is equal to un. And calculate, we get that 0.8 un is 2, so un is 2.5. Okay, so the limit is 2.5. That's how we can find the limit if we are asked to find it algebraically. And that would be all for today. We finished with a nice convergent sequence. Today we learned in this video what a sequence is. A sequence is a list of numbers, but the numbers follow a rule. Terms are the numbers in a sequence. We learned how to use the general term. We learned the recurrence relation formula, in which you have to use the previous term to get the next one. And we learned about convergent, divergent, and periodic sequences. Convergent is when n tends to infinity, un tends to the limit. Divergent is when it doesn't happen, so it goes straight up to infinity or straight up to minus infinity. It doesn't approach any number. Periodic is when it repeats, so 4 6 4 6 4 6 or 1 5 6 1 5 6 1 5 6, when it repeats a certain pattern. Okay, that's it for today. See you in the next video.